7-1 today. This is all about polynomials today. So let's see if you remember anything about polynomial functions. You did a little in your warm-up, so that's good. All right, to be a polynomial function, it must be smooth and continuous. You guys know what continuous means now, right? No sharp corners. I know that sounds weird. But so like a polynomial can't have like, you know how an absolute value comes to a point? Polynomials will never do that. They look just like this, okay? You can obviously have more terms than that, but that's the general idea. Okay. We know about our end behavior already. What else do I want to tell you about polynomials? We're going to look at the fundamental theorem of algebra. A polynomial function of degree n where n is greater than 0 has at least one 0, and that could be real or imaginary, and then your corollary to this. A polynomial function of degree n has exactly n zeros including repeated zeros. I think you guys already knew this. You probably didn't know it was called the fundamental theorem of algebra. Do you guys have questions about that theorem? You guys used to that? Like if you see something with degree 3, you know there's 3 zeros in there? Yeah, okay.
What's repeated zeros again?
Like, let's say you had just y equals x squared. Technically there's 2 zeros, but it happens at 0. Yeah. Yes, multiplicity, yep. All right, so now we're going to find some zeros by factoring. The first one, we've got f of x equals x cubed minus 6x squared minus 27x. So how do you go about factoring that? Take out an x, okay. And I'm left with x squared minus 6x minus 27. So leave that x outside. What does that trinomial factor into then? So your zeros.
0,
9, negative 3. For now, no weird notation that you have to worry about. You can just tell me what they are. Okay. For now. Baby steps. Alright, let's try another one. F of x equals x to the 4th minus 8x squared plus 15. So how many zeros do you think we should have? 4. Good. All right. Is there what? I'm sorry. I wouldn't even, I mean, you can do substitution, but I would just think about it. I know to get x to the 4th, I need x squared times x squared, right? Okay, so you don't have to go through the substitution. And then what multiplies to give you positive 15 and adds up to negative 8? Negative 5 and negative 3, right? Remember, we're finding where these are 0. So you've got two little factors here. X squared minus 5 equals 0, and x squared minus 3 equals 0. So what are my answers? You guys hopefully recognizing like, hey, I should have 4 solutions will help you not forget your plus or minus. Okay. Good so far, guys? Easy? You remember stuff? Sort of? Alright. I'm going to give you f of x equals x times 3x plus 1 times x minus 2 squared sketch a graph. All right, guys, so to start, we need to think about where are our zeros. So where are they? 0, negative 1/3, so those two are kind of close. And then the other one? 2, okay. What's our degree of this polynomial? 4, okay. So when you're graphing it, I would think about your end behavior too. So if it's degree 4 and there's not a negative leading coefficient, where should both of your ends be going? Up, okay. So I know this is happening, and I know that is happening, right? Okay. Then to figure out what's happening in the middle, you've got to think about your multiplicity. Yeah, which one has multiplicity? Yeah, this one, right? Okay. You guys remember bounce versus crossing with point of inflection? Okay, and this is a bounce. So it bounces there, and then it's going to cross and cross. Now, are you going to have your max and mins like perfect on this? No. I want general shape. The end behavior has to be right. That's part of the general shape. Your zeros have to be in the right place. Multiplicity has to be right. And then your y-intercept has to be right. This one's easy because it's at 0, 0. Okay.
Next one always makes it lose zero.
Yeah, when you plug in 0, correct. So having just x out in front makes it really easy because it'll be 0, 0. If that's not there, you've got to do a little more math. Okay? All right, we okay with that one? Easy so far? You guys remember some stuff, so that's good. All right, we've got to talk about rational zeros next. Do you guys remember anything with like P's and Q's last year? Okay. I'm not going to make you write the whole rational zero theorem. We're just going to do some, okay? So, list the possible rational zeros. F of x equals 6x cubed minus 19x squared plus 16x minus 4. When you are listing the possible rational zeros, guys, this unit, it's very important that you read directions. Listing the zeros versus finding them is very different. You're listing all possibilities and then you're done, okay? If I say to find the actual zeros, you may need to make your list and then solve to see which ones work. If it just says list, that's actually not a hard problem, okay? You find them by doing P over Q, all right? Do you remember what P and Q were? Okay. P is your constant. So let's think about our constant here. We are looking for factors that give you that constant. So what could you multiply together to get 4? 4 and 1. Okay, and it is -4, so -1, +4, -4, +1. Like, we can have all combinations of plus and minus, right? So I'm fine with you just putting a plus and minus out in front and then listing 1, 2, and 4. You okay with that? Hannah, you do not look okay with that. The plus or minus or the 1, 2, and 4? Or all of it?
So P is your constant.
Mm-hmm.
So I get the quadratic being like 4, so why do you go on?
Well, the way you multiply to get 4 is 1 times 4 or 2 times 2. All the factors, yeah. Okay? So then it's over your leading coefficient. So my leading coefficient here is a 6. So again, plus or minus, how can I get 6? 1 and 6. Okay. So I'm going to list 1, 2, 3, 6. Okay with that? Then your actual answer is making the fractions out of these. So equals. I'm fine with plus or minus out in front for the whole thing. And then just create your fractions. So what's 1 over 1? 1, 2 over 1, 4 over 1, 4 over 1. Okay. Then I move on to my next denominator. So what's 1 over 2? Okay, 2 over 2. 1, I already have that, so don't list it again. And then 4 over 2, 2, which I already have, so I'm not going to list that again. So then I move on. 1 over 3, 2 over 3, 4 over 3. On again, 1 over 6. Do I need 2 over 6? No. Do I need 4 over 6? No, because that'd be 2/3. I already have those. So those are your possible rational zeros, positive or negative for everything in that list. You do not have to write them in the exact order I just had, but please have some sort of system for figuring out all your fractions. Don't just jump around. Every year I have somebody who's like, well, I did 1 over 1, and then 1 over 6, then 2 over 3, and then 4 over 1. What are you doing? So you lose answers if you do that. Have some sort of systematic way that you're going about setting up all your fractions. plug it in or do synthetic division. Remember? Yeah. Remember? A little bit. All right, are we okay with A? Let's try another one. I'll have you guys try one. All right, let's do f of x equals 3x cubed minus 17x squared plus 25x minus 25. Okay, guys, one thing you need to be aware of for anything dealing with polynomials, if it's not written in order, like in standard form, you need to put it in the right order, okay? Because your leading coefficient isn't just whatever term is first. It's the biggest exponent that you've got to look at that term, okay? All right, so you guys try your P over Q here. Let's see for this one. You actually have 12 answers, but yeah. Right, so like this is the list of all possible rational zeros. There might only be one of them that works, and you have two imaginary. Okay. All right. How do we do on this one, guys? Plus or minus 1, 5, 25, 1/3, 5 thirds, 25 thirds. Okay. Okay. Let's try. Where am I on? All right, we are going to divide with long division. Woo-hoo. So we've got 6x cubed minus 2x squared minus 16x minus 8 divided by 2x minus 4. So do you remember how to set up long division?
That's as far as it goes.
Oh, okay. Well, we will walk through it with baby steps. All right, so the 2x minus 4, that's what you're dividing by. That goes on the outside. 6x cubed minus 2x squared minus 16x minus 8. That all goes under. You need to make sure that you don't skip any exponents along the way. So this is fine. It goes cube, squared, linear, constant. And then all you're looking at, you should be thinking about this first term here, 2x. What do I multiply 2x by to get 6x cubed? 3x squared. Okay, so that goes up there. And I don't care where you write it up there. It doesn't have to line up perfectly over anything, just 3x squared. So then you take 3x squared times 2x, which we know is 6x cubed. And then you also take it times -4. So I'm going to get -12x squared. Are you with me there? All right. It's long division, so do I add or subtract here? Subtract. And I do subtraction and then put this whole thing in parentheses so that you don't mess it up. Because honestly, the biggest mistakes are your signs in this. You guys multiply just fine. It's adding and subtracting that becomes challenging. So 6x cubed minus 6x cubed, that should be gone. If that ever doesn't go away, you made a mistake somewhere. And then -2x squared minus -12x squared. What do I actually get? Okay. And then you bring down -16x. You with me so far?
Yeah.
Okay. Now we start over. So I think, what do I take 2x times to get 10x squared?
5.
So I'm going to write plus 5x. All right, and then we multiply. So 5x times 2x is 10x squared. 5x times -4 is -20x. Then subtract. Don't screw up your signs. 10x squared minus 10x squared is gone. What about -16x minus -20x? 4x. Bring down that -8. All right, what do I take 2x times to get 4x? 2. Question. Then I multiply. So 2 times 2x is 4x. 2 times -4 is -8. When I subtract, what do I get? Nothing, right? 0? Okay, that means there's no remainder. When you divide, this is your final answer. Okay? Is it coming back to you?
Yeah.
Or horrible memories coming back to you? I don't know which one. That too? Oh, okay. All right. Hopefully it's better this year. All right, let's try another one. We'll just write this one the way it's supposed to be. You know you can ask questions, right?
No.
What? Oh, well that's, yeah, if you don't actually know. You would want to put like 0x squared or 0x whatever, like a placeholder. Otherwise, when you go to subtract, things are not going to line up, right?
If you like bring it down, it's gonna be like plus 0x squared.
Yep. You're ready.
I know that this whole thing works, but how can we only deal with like the first number, like the first part, and then you use both parts to multiply it out?
So you're sort of using both parts, you just can't think about both parts. Like think back if you did, like, I don't know, like if I did 108 divided by 3 back that way. How many times does 3 go into 10, or 3 times what will get you closest to 10? 3. Then you multiply, subtract. So like you only do, are you talking inside or outside only part of it?
Like, the x equals 6, you multiply the x numbers. But then you have to multiply it by the 6 also to get that number.
So you have to have it match, like the one you really care about it matching is this first one, right? And then, so you multiply there, that 6 is going to now give you your new first term. So you are dealing with it. You see what I mean? Because if you subtract, okay, so that's going to give me x squared. So do you see how the 6x squared created your new x squared that you're thinking about? Okay. All right, did you guys get x squared plus x minus 2? Okay. Do you want an uglier one to practice to make sure you guys got the trickier one? Really ugly. Super, super ugly. All right, let's do...
Dude, we need that really fast. It's just like, oh, we just
All right, that's fairly ugly. That is in the wrong order, yep.
Yes.
Yep, did that on purpose for you. Wrong order. Did I skip some stuff too?
Yeah.
Yep. Okay, that matters.
Fill it in.
Yeah.
What do you mean?
So I'll give you a second to write it, and then I'll write what it should actually look like when you start your long division.
0, 0, next.
Yeah.
Yes, you can. Alright, I guess you can. You do that.
Oh.
Oh, you do
That's pretty. Alright guys, that's what it should look like when you start.
Wait, do you need it in the denominator as well?
Or you have to be aware that things, like, when you multiply, things won't line up. You know what I mean? Because, like, so, your first term here would be 5x to the 4th, right?
Yeah.
So you multiply 5x to the 4th with that, that's fine. If you don't have that there, you're going to get negative 30x to the 4th. That clearly does not line up. You see what I mean? So, like, you want that placeholder there, just so you don't screw it up. near the end, you get some pretty big numbers.
There we go. Just the way I remembered it.
This is just how you're. So this one gets really gross, you know, but.
Oh wait, no, I got that. It's trashy.
Yeah, so it's 177 times 6. What?
Oh no.
So 642. Yeah, that's not right. Guys, I won't give you one with 177 times 6 without a calculator. This is just me making one up and what you get. It happens. Awful. So guys, what is 6 times 177? Okay, we have a calculator. I have a gigantic calculator. I don't know if I trust you this morning, Marvin. I'm gonna cheat.
Bet my money on it. It's right.
It probably is. Marvin is always right. 1,062. So we do that. It's really 1. Okay. And then plus. I'm going to be squeezing in your remainder here, guys. How do we do, guys?
I'm getting there.
Mr. No. You asked for ugly. I think I delivered. I know you can't read my remainder up here. Do you guys remember this is how you write your remainder, though? Plus whatever your remainder is over what you're dividing by.
Yeah.
You don't write R and then the remainder, okay?
Oh, that was so
I was so cute.
yeah. 60 become the farther you get back, just the next one. That's what I'm just
True. Alright guys, did anybody actually get there?
Yeah.
Okay. Alright. Give me a minute.
My arms hurt.
Writing.
So I can't.
It barely fits on one screen, so just squeeze it and write it. Sorry guys, I don't know what number I'm on, so. Alright, anybody questions on that one? Obviously, not messing up your signs is pretty key, because once one sign is off, everything is wrong after that. These are not fun to grade. You okay? Yeah. Alright, ready for synthetic division? Synthetic is so much easier than long division.
Persist on that one. Yes.
All right, guys. Moving on here to synthetic division.
Let's go.
All right, your coefficients, so your 6, -2, -16, -8. Those go along there. What goes on the outside? What am I doing my division with? 2. Yes, it's what would make that divisor 0. Okay, so a 2 goes out here. All right. To start, you just bring down the 6. Then it is 6 times 2, which is 12. Now, do I add or subtract? Add. Good. So I get 10. 10 times 2. Add. 4 times 2. Add. Okay with that? How do you write your actual answer now, though? It's not just 6, 10, 4, 0. 6x squared, yep.
Plus 10x plus 4.
And then the remainder. Okay, good. If you don't think that's faster than long division, I don't know what to tell you.
Why do we even learn longer?
So synthetic division doesn't work with everything. Synthetic division only works if it's a linear term that you're dividing by. So like if you had x squared, you can't do synthetic. And if your coefficient isn't 1, you should do long division. There's a way to, like if you were dividing by like 2x minus 3, there's a way to do synthetic with it, but you're going to mess it up more than you are long division. Okay? So the only time you can do synthetic is when you have a nice little linear term with a leading coefficient of 1. Okay. Let's try another one of those. Do one more. Let's say, no, we've got a couple other theorems to talk about. Did you guys remember to put your 0 in? All right, guys, 2x squared minus 11x plus 33 plus negative 89 over x plus 3.
That's good.
Yes? No? Maybe? Think about it for a second while I take attendance. Oh, and guys, just a reminder, this has nothing to do with this lesson, but don't forget today is a Stay Put Monday. Just a heads up.
There's a purpose. Okay, how much that little one is.
Yeah, you're supposed to be improving your like
We're gonna have another one of those.
Life skills.
your
Yeah.
your functioning.
I hate those.
Why did we do this?
Executive functioning. I'm missing a word. Executive functioning. All right, guys. Any questions on synthetic? Easy. The only way this will get trickier, I could give you. You could be dividing by like radicals. You know, it could have been x plus root 3, and you'd have to deal with that. I could give you imaginaries. You're gonna see it on your homework. So, yeah. All right. What do you guys remember about imaginary zeros? Okay, yes. Do you ever just have one? Okay, yes. They always come in pairs, remember? I squared is -1, true. True, yes. But they always come in pairs. So like if you know I is one of your zeros, so is negative I. Okay, the conjugates are always pairs, like 3 plus I, okay, then 3 minus I is going to be 1. Yes.
Are we going over that?
Yeah, we're going to do more with it, but we're going to do some other theorems here. So guys, next we got to jot down the remainder theorem. So it doesn't work if you've got x squared or higher, and if you've got a leading coefficient other than 1.
This doesn't have anything to do with the lesson.
Oh, I forgot to. Yes, thank you. I will do that at the end. Remind me again at the end when I forget again. Okay. If a polynomial f of x is divided by x minus c, the remainder r equals f of c. What does that mean? Plug in the thing, it's equal to the thing.
You plug in like the
No, that's okay. Right. Yeah, so guys, if you just took like, you know, if you had x minus 3, if you took your 3 and plugged it into the function, did f of 3, whatever that number is going to be the same as your remainder. Why might that be helpful?
check your answer.
Check your answer, absolutely. What else? What if we get a 0 when we plug it in? What does that tell me? Good, and 0 is 0. You mean like it's a factor, sort of? Yes. Yeah, so guys, you can always check. We'll be looking to see if things are zeros or factors of your given polynomial, and a quick way to test that is either do the synthetic division or plug it in. I actually think a lot of the time synthetic division is faster than plugging it in if you have big numbers and big exponents. Okay? All right, one other theorem for you here, the factor theorem, which is kind of what we just talked about. A polynomial, let me just send this back. Thank you. F of x has a factor x minus c if and only if f of c equals 0. So again, that's what we were just talking about. If you plug it in and you get 0, then that is definitely a factor of your polynomial. Okay. Let's try one relating to that. Show that x plus 3 and x minus 2 are factors of f of x equals 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18, and then state all of the zeros. Okay. So if x plus 3 is a factor, what would I expect my remainder to be? 0. X minus 2 is a factor. What would I expect my remainder to be? 0. And then if I'm trying to find the rest of the zeros, I don't really want to try to solve that equation that's up there right now with factoring, or you can't use the quadratic formula, you can't complete the square. So let's use our synthetic division to help us find those other zeros. Because how many zeros should there be? 4. Okay. So I'm going to start with synthetic division with the x plus 3. So 2. Yes, it will. All right, so if I do synthetic division, so I bring down my 2, multiply, add, multiply, add. Now guys, if you're going through your synthetic division and they tell you this is a factor and you get to the end and you have a remainder, do you think you did it right? No, you should go try again. Okay, so we've shown x plus 3 works, right? Okay, you could write this out. This is 2x cubed plus x squared minus 7x minus 6. You don't really have to do that. We could just jump right into our next synthetic division. And guys, you're going to want to do it with the answer you just found. Okay, because that's going to get you then to an x squared, something you can actually factor or solve with many of your other methods. So we are looking for, wow, that's really loud.
I swear. Oh,
Is that a pencil sharpener? Or is that... Are you sure? Oh, okay. They're fixing the drinking fountain out there.
Oh, that's awesome.
It does sound like a pencil sharpener. Yes. Soothing?
Yeah.
It's soothing. All right. Is everybody okay with this 2, 5, 3, 0? Are we all there? Okay. So that is 2x squared plus 5x plus 3, right? Well, now I need to figure out where that equals 0. I don't have any other factors to use, but can I factor this? Yeah. I don't care how you factor. You can guess and check. You can group. You can draw some weird circle or box on your paper. Whatever you feel like doing, as long as you get there. Since my 2 and 3 are prime, I think guess and check is actually the easiest way to go, but it's totally up to you guys, as long as you get here. Are we here? Okay. Not quite yet? All right, so my zeros are at -3/2, right? -1. Where else though? Because remember I'm supposed to have 4. -3 and 2. Okay? Guys, what if you had gotten here and it doesn't factor? What'd you think here? Yeah, you could do quadratic formula. What else do you know how to do that you don't like, but you could do? Yes. You'd have to move the 3 and divide by 2. This would be a terrible one to complete this method, yeah.
So you divided it by -3, you divided that by 2, it doesn't matter.
Nope, if you had started with the 2 and then the -3, you still would have gotten to the 2x squared plus 5x plus 3. It's multiplication, you know, you can do 3 times 2, 2 times 3, it doesn't matter. So, yep, you're good. Okay, guys, we're getting close. I know this is a long day of notes. All right, guys, we have what is called the upper and lower bound test. This is your last, like, lengthy thing to jot down. I know. Upper and lower bound test. I know. We're almost done, guys. I promise.
I'm on a new piece of paper.
Oh, man.
I've been on.
So, guys, if I gave you just a polynomial, like, let's say, I don't know, to the 4th degree, and I said list all the possible rational roots, and you came up with your P over Q and your list, and let's say it had like 24 things in it, okay? And then I said find which ones work. Do you really want to check all 24?
I know.
I know. You are welcome to. You would be doing it with synthetic division or plugging it in to see what works. What you can do to speed up the process a little is called this upper and lower bound test. When you do synthetic division with one of them, you'll know if it's an upper or lower bound, meaning like you don't have any more zeros past that. Like, you know, if you plug in 1 in the middle and it shows up as an upper bound, don't check anything higher than that because they're not going to work. Okay, so this sort of helps you eliminate some of your possible rational roots. Okay, so the way it works, this is kind of a long one to write down, guys, so let f, yep, we can do it, be a polynomial function of degree n greater than or equal to 1, real coefficients, and a positive leading coefficient. Leading coefficient, yes. Suppose f of x is divided by x minus c. And I wrote 3. How about c? There we go. All right. So if c was less than or equal to 0, and every number in the last line of the division is alternately non-negative, and non-positive, and I will explain this. Then C is a lower bound. All right, let's write the part for upper bound and then I'll explain. If C is greater than or equal to 0, and every number in the last line of the division is non-negative, then C is an upper bound. And again, I'll explain. I'll make sure everybody has it written down before I explain. Yeah, how's your hand doing? It's a bad day for your arms to be tired. All right, guys, so this isn't too confusing. We're talking about C being negative. Okay, the equal to 0, really, that doesn't make sense if that's there. 0, that's, you're just dividing by x. But anyway. So every number in the last line of division, that means that thing you end up with after you do your synthetic division. If they are alternately non-negative and non-positive, okay, it means they alternate. The reason we say non-negative and non-positive is so that you can include 0 in whichever one you want. Is a 0 positive? Is 0 negative? Is 0 non-negative? Is 0 non-positive? Okay, so that's why we have the weird terminology in there. So like if you see -4, 0, -3, 7, that alternates. Okay, does that make sense? All right, then, and if that happens, then you know C is the lower bound. Then if we check with a C that's positive, we do our division and every number at the end is non-negative, then C is an upper bound. So if you have like 3, 0, 7, 2, okay, that's an upper bound. So the zeros kind of get to be included as whatever you need them to be. All right, let's try one. This will be the last thing we do. Am I on like number 6? Do you guys? 7? Okay. Determine if -1 is a lower bound and 7 is an upper bound. So your f of x is 2x to the 4th minus 11x cubed plus 2x squared minus 44x minus 24. Okay, let's do the -1 first. So I'm just doing synthetic division. So bring down the 2, multiply. Subtraction everywhere. It's a Monday, guys. Let's see, 44 minus 15. I don't know. It's a Monday, so yeah. Okay, good. Sorry for that. All right, guys. So, do my signs alternate?
Yeah.
What does that mean? -1 is a lower bound. So what that means from a usefulness point, don't check anything lower than -1 for being a 0 on this particular function, okay? So, like, if you had done, you know, your list of your P's and Q's, you have your huge list, and you would have a huge list for this, with it being 24 and 2. You wouldn't want to test anything smaller than -1, because -1 is a lower bound, meaning there will not be any zeros lower than -1. Okay? So then let's check 7. And you know we've written a lot today because I can't extend my page anymore, so I'm going to just try to squeeze it in. Is that 161? And guys, let's think about it here, because if you're like, oh man, these are big numbers. So, -44 plus 161, that's going to be a big positive number, right? And then I'm going to multiply it by +7 and get an even bigger positive number. What's going to happen with both of these? Yeah, they're going to be big positive numbers, right? I don't care if you write them out as long as you understand they're positive. Because then everything there is non-negative, correct? So what does that tell me about 7? Yes. Yes.
So it has to be negative to be a lower bound, and then positive to be an upper.
Correct. Yep.
Can we choose random numbers, like, so that when you give us a bound?
Sometimes I'll give you them, sometimes I'll just have you use your P over Q list, so you'd be picking from that list.
So would be like the lowest numbers?
I wouldn't pick the lowest, because then, cool, that's a lower bound, I don't have anything lower. Yeah, okay. So kind of pick in the middle, work your way out. Yes.
There's never really guess for like
The P over Q. Yeah, so like if you have your whole list, don't pick the ends, because those are obviously already the ends. You know, so kind of start in here, and then if you can, work your way in. And you may find a 0 doing your synthetic division anyway. So you have to do the synthetic to find the 0, so while doing it, you're like, oh, that's a lower bound. Cool, that helps me. Okay? All right, guys, homework is on your assignment sheet. I know that was long. Thank you for sticking with it.
like